Welcome to the Explainer. We hear the term machine learning thrown around all the time, right? But have you ever stopped to think about what it actually means for a machine to learn?
I mean, that's the big question, isn't it? We get how humans learn through trial and error, experience, but how in the world do you teach a computer to think? How do you build that ability from scratch with just code and data?
Okay, so to get our heads around machine learning, or ML as you'll hear it called, we got to zoom out a bit first. We need to see where it fits in the big picture, and that picture is called artificial intelligence.
So, AI, think of it as the huge, ambitious goal. It's the whole science of trying to make machines that can reason and solve problems on a level that's, kind of like us. It's the whole universe of making machines smart.
Right, so this is a key point. Machine learning is not the same thing as AI. Nope. It's a really, really important piece of AI, a powerful field that sits alongside other stuff like robotics and computer vision. All right, so if ML is just one type of AI, what's the big deal? What makes it so unique? Well, if we're not just writing a bunch of if this, then that rules, then how does a machine actually learn? This idea has been around for a while. Way back in 1983, a pioneer named Herbert Simon pretty much nailed it. He said learning is all about a system changing itself, adapting, so that it can do the same task better and faster the next time. It's learning by doing. Simple as that. And this later definition gets to the absolute core of it. The key ingredient is experience. But what's experience for a computer? It's not memories or feelings. It's data. Piles and piles of data from examples that have already been solved. And that, right there, is the magic trick of machine learning. See, with old school programming, we had to write out every single rule. With machine learning, we flip that on its head. We just show the computer a ton of data and say, here, you figure out the patterns, you find the rules.
Okay, so we're feeding machines all this data so they can learn. But what are we asking them to do with it? Well, it pretty much boils down to two main jobs.
So you've got two main flavors here. The first is descriptive. The machine looks at all the data it already has and finds interesting hidden patterns. Think of it like organizing your customers into different groups you didn't even know existed. Then you've got predictive. This is where the machine takes what it's learned to make a guess about something new, something it's never seen before, like is this new email spam or not?
So how do machines actually do all this? Well, they don't all learn the same way. Let's dive into what you could call the 5 primary learning styles that make modern ML possible. Yeah, you can really think of these as 5 different philosophies or strategies for how a machine can learn from all that data we're feeding it.
First up, we've got symbolic learning. This one is all about building a model that we can actually read and understand, like a big decision tree or a set of if-then rules. It's basically drawing a logical map to show how it gets from A to B. Number 2 is instance-based learning. This is kind of like learning by saying, what does this remind me of? The machine keeps a memory of all the examples it's seen. When a new thing comes along, it just finds the most similar things in its memory to figure out what it is. A classic example of this is K-nearest neighbors. Then there's the connectionist approach, and this is the one you've probably heard about because it's inspired by our own brains. It uses these giant tangled networks of artificial neurons that all work together. This is the powerhouse behind what we call neural networks and deep learning. All right, number 4 is genetic learning, and this is just cool. It literally mimics evolution. You start with a bunch of different potential answers, and you make them compete. The bad ones, they get tossed out. But the good ones, they get to reproduce, mixing and matching their best parts to create a new, hopefully even better generation of answers. And last but not least, we have statistical learning. This approach is all about pure math. It uses statistics and probability to build a mathematical model that fits the data. The whole game is to find the perfect equation that can best describe the patterns and make solid predictions. Phew, okay, that's a lot, I know. 5 totally different ways of thinking about learning. So let's just do a super quick rundown to lock it all in. So you've got symbolic, which is learning with rules, instance-based, learning from things that are similar, connectionist, which learns with brain-like networks, genetic, learning through survival of the fittest, and statistical, which learns with pure math models. Those are the big 5. We're getting ridiculously good at this stuff, at building these learning machines. So the really interesting question isn't just how they learn anymore. The question we have to ask ourselves is, what's next? What are the big, important problems we want to teach them to solve for us?